Another key feature of Simulink is the ability to work with signals in parallel. So let me try and show you how this is possible. I'm going to drag and drop a gain block onto my signal, and instead of using a gain of 1, I'm going to use a vector of gains. So what I've just done is now multiplied the output of the integrator by 8 gains starting from 3 to 10. And at this point, Simulink provides easy visualization of which signals are vectors and which signals are scalars by turning on some of these displays. So you can see that this signal and the output of the integrator is a scalar value that then gets multiplied by this gain, converting it into a vector value of 8 signals running in parallel that goes to the saturation and remains the same. Now, this is still fairly trivial, and I might make this a little more complicated by changing the saturation limits. So instead of using fixed saturation limits, let me use random saturation limits between -10 and 10, for example. And what I'm doing here is using the rand function from MATLAB to generate 8 random values between 0 and 1 and multiplying that by 10 to create the upper limits, or 10 random upper limits, and doing the same thing to create 8 random lower limits between 0 and -10. So let's simulate this model and look at the output. Let's simulate this a couple more times here.